Welcome to summation notation. So again, in the previous video, I talked about the fact that as we take more and more rectangles, we're going to be adding up more and more rectangles, and we would want to learn summations. That's what we're working with here. So the notation, we use a capital Greek letter sigma, which kind of looks like a weird E to indicate sums. And we go from, say, I equals some number m up to n. And we'll just label this a sub I. What this notation means is we are going to run through a whole bunch of numbers. So we'll start at a sub m, whatever that is, and then add a sub m plus 1. A sub m plus 2, just running through the sequence. And we'll just keep going up until we add a sub m. So this is the notation they use. It doesn't make a lot of sense, I think, until we see actual examples. So this first example, let's go ahead and just evaluate the summation from I equals 1 to 4 of 2i. I'm going to actually write this in words here. So this is the summation from I equals m to n of ai is how we would say that. So again, let's do the summation from I equals 1 to 4 of 2i. So we're going to look at I equals 1, I equals 2, I equals 3, and I equals 4. Those are all the numbers running from 1 to 4. We only use integers for summation. And now we are going to do 2i. So 2i, we are looking at 2 times 1, 2 times 2, 2 times 3, and 2 times 4. And then the summation of 2i, we're just going to add those up. So 2 times 1 is 2, 2 times 2 is 4, so we'll add that. 2 times 3 is 6, we will add that. And 2 times 4 is 8, so we will add those 4 terms. So summation just means figure out what each of those terms would be by plugging in the relevant I and then add them up. So this winds up being what, 20? So that summation is just 20. So let's go ahead and do another example. And we want to evaluate the summation from I equals 1 to 5 of I squared. So this time around, we are concerned with I equals 1, I equals 2, I equals 3, I equals 4, and I equals 5. And then for each of those, we are going to do I squared. So I'm just going to write the sum from I equals 1 to 5 of I squared. We're going to do I, so 1 squared. Then we'll do 2 squared, followed by 3 squared, followed by 4 squared, followed by 5 squared. So we are looking at 1 plus 4 plus 9 plus 16 plus 25. 1 plus 9 is 10, 4 plus 16 is 20. So all of those together will be 30, plus 25 would be 55. So this summation is equal to 55. For one more, we're going to go ahead and just rewrite a sum using summation notation. So here we have 1 plus 8 plus 27 plus 64 plus 125. We need to look for a pattern. So we're going to find the pattern first. So you might notice that all of these are cubes. So this is really 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. So if we set I to be 1, 2, 3, 4, and 5, then each of these terms is just I cubed. So the summation we're looking at, we had to run from I equals 1 up through I equals 5. And then we are just doing I cubed. So this is writing 1 plus 8 plus 27 plus 64 plus 125 using the summation notation that we have been working with. So this is just sort of brief what summation notation is. It's not so bad when we're just running through 4 or 5 numbers, but you can imagine if we wanted to do from I equals 1 to 20, we wouldn't want to actually have to list out every single term. So in the next video, we're going to get some properties and shortcuts we can use for evaluating some basic summations.